Welcome, Jacob.
Thank you. So yes, as mentioned, I'm not Brendan, and my name is Jacob. I'm a senior software engineer at Mantle Group. And yes, Brendan and the organisers have given me the opportunity to speak today. What will be, I guess, my foray back into the realm of public speaking ever since my university days anyway. My talk may be a little less serverless, but I hope you learn a thing or two regardless. I myself, I've got about 6 years of experience at this point, dealing primarily in the back-end side of technologies and work with APIs and API integration, as well finding myself doing a lot of the DevOps infrastructure and general automation on side of things as well. So today I'll be talking about the .NET Query String Detective, or how I built an online query string evaluator. First, some context. I was working with a colleague a few months ago, and we were discussing how we should best deal with kind of binding query string parameters for our .NET API, and more specifically, how we should deal with the provision of a collection of values, right? Whether we need to comma delimit them, whether or not that's inherently supported by the API, whether we need to implement some sort of parsing ourselves, etc. That led me to do a bit of debugging and put together this table here. So as we can see here, a few examples of the way .NET will bind given query strings, both to a string type and an enumerable type, in this case a string array. And we can see how it deals with the provision of a comma delimited values, as well as the provision of multiple query parameters, and how that may result in whether it comma delimits that for you or splits that into distinct elements within that array, etc. Now, this is specific. This example here is, I do mention it is minimal APIs, because you may be surprised, and I certainly was, there are actually discrepancies between minimal APIs and controllers when it comes to query string binding. And that led me to create that, in creating that table, I was inspired to create an online tool to allow you to test that query string binding on the fly, right? There wasn't really any alternatives that I could find, and so this really kind of shortens that feedback loop of having to, I guess, debug your own applications and throw at various query strings and see the results. So,
for URLs?
Sorry?
Is that for URL query strings?
Yes.
Can you repeat the question you asked?
Yeah, just to clarify, it is for URL query strings, URL-based query strings. So if I pop open the tool here, we can see just a small example here. If we give it a query string, and again, we're binding the parameter q, we can see the results of that binding across a multitude of types. So by default, you'll see what succeeds. So we get a string value here, how it looks, if you're binding to a string array. You'll also see how that looks if you're attempting to bind to other types. And you can see more detailed error messages as well. So again, very helpful if you're to see just quickly how the APIs will deal with the provision of multiple parameters. So we can see here, it's actually discrepant. So minimal APIs, if we're binding q equals hello and q equals world to a string, minimal APIs will comma delimit that for you, and you'll get hello, comma world. Whereas controllers, and this is kind of common across any kind of type you're trying to bind to, controllers will seemingly just take the first element it encounters. And as well, if you are knowledgeable, controllers does have a separate, it supports a separate sort of syntax for binding to distinct array elements, but where minimal APIs don't. So again, you could kind of test that out here. Luckily though, if you are binding to an enumerable type, no surprises there. You will get those elements in your as distinct elements as part of that array. So in creating this tool and playing around with query strings, I found a few interesting examples, particularly around binding floating point values. So a few examples here. Q equals 1. Hopefully no surprises. You'll get 1. As well, while binding to these examples, I say bind to double. The results are the same across decimal or float. Example, Q equals 1.5. Again, hopefully no surprises, 1.5. Now, Q equals 1 and Q equals 0.5. That's also 1.5. The numeric value of 1.5.
Is concatenated.
Seemingly. Last example, Q equals 1 and Q equals 0.5. You will get the numeric value of 10.5. I don't know if this was intentional. Again, this is minimal APIs. Again, controllers will just kind of take the first value, so you'll just get 1 or 1.5 in that second case there if you are binding to controllers. But as part of minimal APIs, these are the results you'll see. So again, it may just be a side effect of that comma delimiting that it will do for you, whereby it's kind of parsing that value after doing that concatenation in some way. But interesting nonetheless.
Strings are loyal.
So that being said, it kind of comes into how it was built. Because I guess as a user of this application, if you're seeing some interesting results, I guess why should you trust it, right? You may think, oh, it's just the tool's wrong. Now, the way it's built is that it's built on top of .NET's test server. Now, if you're not familiar, the test server is a capability that kind of fuels .NET's integration testing capabilities through the web application factory. And we can use that to, I guess, we kind of have our server here. So we can create a server, we can configure services, configure the app pipeline. We can give our server to the test server. And using that test server, we can create HTTP clients and then send requests using that client like you would otherwise, in a general workflow. You can send requests to that server. And those requests get executed kind of in memory against that server. So again, great for integration testing and whatnot. But again, a great platform to test how the server is going to bind our given query strings. Now, so this being said, what we need here is we need a test server for our minimal APIs, or a test server built around minimal APIs, and a test server built around controllers. So now, an early iteration of the tool used reflection. I guess short of hard coding all of the delegates and the actions that I need, because that would be no fun. Another approach, the first approach I took was reflection. So given, I guess, the list of types that I want to set up as kind of target types to bind to, first iteration was reflection. So we have a create delegate method here where we can use a generic type to create the delegate that we need. And again, this is a minimal API request delegate. So it sets up that from query kind of binding for us. Now, again, we kind of refer to that method using reflection and kind of dynamically instantiate that at runtime to create all of those and register all of the delegates that we need. And so while that works, it does get very complex trying to achieve the equivalent with controllers and controller actions. So it's for that reason, as well as the other reason of as accurate as it may be, as a user coming in and I guess looking to trust this online tool to test the query string binding, they would see this and think, I don't write my APIs like this. I'm sure it's just some side effect of using all this reflection. So for those reasons, I looked to source generators. Now, if you're not familiar, source generators, again, it's a .NET capability, and it's called, I guess, called different things in different languages. But using source generators, we can kind of affect and modify how our code compiles. And more importantly, in this orange section here, during the compilation of our code, we can have a source generator that we define. It can analyze that source code. And more importantly, it can actually we can use it to create more source code that our application then subsequently uses in the remainder of its compilation. So to achieve what we need for the minimal API delegates, and again, so the source generator is kind of represented as a class, and within that class, you have an execute method. Within that execute method, you can kind of spit out extra source code, right? So we do that here. And so within this string template, we can just write the code that we want to write. So in this case, we're just creating a static element here where we can just loop through and define all of the request delegates that we want. And so the result of this looks a little something like this, whereby this is code that our code can also reference. And what we get then is at runtime, our code isn't using reflection. At runtime, our code is using this code, which looks a lot closer to how you would actually write your APIs. And equivalently, we need it for a controller. So in the controller case, we generate the controller itself, and we just loop through creating all of the actions that we need. And so the output looks a little something like this. Now, naming conventions aside, again, looks a lot closer to how you might actually write your controller and your action methods in the day-to-day. So with that all being said, we have our test servers. I guess bringing it all together, we can, in the case of what I've built, slap that in an Azure Function app, slap a client on the front, and we get our query string evaluator. If you're interested, I'm not going into too much depth here, but the client side is running just a static Blazor WebAssembly application. And again, that just talks to an Azure function, which kind of takes your input query string, sends that to those in-memory test servers, and just gives back the kind of, I guess, collates the results, gives that back to the client. So, in summary, I've discussed a bit about .NET's query string binding, both across minimal APIs and controllers, .NET's test server, which will allow you to execute in-memory requests, source generators, whereby you can create code with code, all, I guess, culminating in the .NET Query String Detective tool that I've built, which will allow you to quickly and easily test query string bindings. Thank you. Yes, any questions?
Yeah, I've got a few. Well, first of all, what was the business case for the Query String Detective? What was the problem that you were trying to solve there?
The problem was I just wanted to, I guess, well, it was for fun. Firstly, it was for fun. It was not for work. But it was just, I guess, a personal challenge of mine. I didn't see any kind of alternatives to I guess, shortening the feedback loop here of doing this kind of testing. I guess short of building your own API and doing debugging, there wasn't an easy way to check the results of this input and output. Yeah.
The other thing is, have you looked into like using API Explorer or like controller descriptors, action descriptors to plug into the ASP.NET Core HTTP process loop?
That I have not. I understand API Explorer. That's, I mean, as far as I understand that, it's just a bit of static analysis, right?
No, it's more of a filter that you plug into a ASP.NET Core server, and that can actually look into what Kestrel has produced as the routes and the queries and everything. related to your server, the APIs and such. And in that case, you wouldn't have to, let's say, generate the routes if they already exist on the actions and controllers.
Right. Well, I guess in that case they don't exist yet because I'm creating them. But yeah, no, I've not looked into that alternative.
Yeah, cool.
Good. Yes.
Have you tried to run it in Blazor? Like if you're running Blazor, guys.
Yeah, that was the first plan.
Right.
So running client-side Blazor WebAssembly, it's running proudly JavaScript free. The plan was to put this entire app just in the client side. That way, the feedback loop again will be even shorter. Unfortunately, the test server and the assemblies that I needed to use the test servers, they didn't have a WASM target, so I couldn't compile for WebAssembly. So that, I guess, forced me to require a server.
Do you see different results in different versions of the framework?
That is an extension that I'd like to make. This is running on .NET 8, but yes, equivalently, I could create test servers for each, I guess, different assemblies built on different .NET versions, and then you could explore are there any discrepancies there. So yeah, that's an extension that I would like to make to the application.
Yeah, I also wanted to ask whether the query string parsing behaves differently on different flavors.
Right off the top of my head, you'd hope not. But just like with minimal APIs versus controllers, there were some funny discrepancies.
Do you agree with some of the outputs?
I think the floating point stuff is pretty interesting.
Yeah, and you said you could avoid the JavaScript in your application.
Yes. So C# across the board here. Yeah. Well, thank you very much. I will now pass to Brendan. Or
I'm also Brendan.
yes.
But anyways,
We're all Brendan today.
we're all Brendan tonight. Thank you very much, Jacob.